So do you see Blackboard good? Okay. Okay, very good. So everybody hearing me? Okay, good. So let's just start. Then I will try to remind you what we learned last time. So the last time we have seen that. So we are just on the one of the very important subject, which will be the differential equations, and it will be related to the modeling. And so we will try at least in a very naive way to modeling what is the evolution of the coronavirus. But let me just start with the subjects which we learned last time. So the last time we deal with the arc length of the curve. And if you remember that, are you hearing me good? And do you see the whiteboard quite well? Fantastic. So then, if which means that if we had the curve y is equal of fx, where x between a and b, so we have some curve. Let's just say like this. We have this curve, and so this is the a, and this is b. So this is our function y of f of x. Then we had the formula which is L is equal to integral from a to b, the 1 plus, and then we have to take derivative. We have already with you such the consensus that sometimes I will write instead of derivative like this, the 1 plus the fraction is given, the x. Sometimes, if you don't mind, I will just instead of this, I will write f prime of x. So if you have the function which is that has if you have the curve which is the written by y is equal f of x, then so this guy you can just write this is the same, and we computed for this for a given curve the length of the curve, if the curve has this form or the more complex form, it doesn't matter. And for some cases we computed this. Please, I would like to emphasize that in the test 3, which we are still thinking that it will be happen, and also the final exam, we are thinking in which way. Then, if we have some solutions, we are working on it. Then I will inform your Moodle. And then, so for some simple curves, we computed. We last time computed that the length of the circle is the 2. If you have the circle with our radius r, so then we have shown that using this formula, one can show that it will be the very famous formula which you learn in the elementary school. Today, I would like to just, and then the last time we also learned surface of a revolution. And the surface of revolution, I told you that when we are speaking the surface of revolution, then so we have again some curve like this. It will be y of again y of is equal f of x, and now we are just trying as we did last time. I showed the very geometrical. And I received from you the feedback that so that this what I showed in the paper, like how to compute the surface of the cylinder. You really enjoyed. I received the feedback, and now the surface of revolution. Do you remember we had also the concept of the volume of revolution, right? Volume of revolution. So this is the same. You can understand the same spirit. When we are saying the volume of revolution, so we are, so this is we are considering, so the reflection, not only this curve around of this x-axis, also what is the inside, so that this is all area. When we are saying the volume of revolution, we are considering the area under this graph, y is equal to f of x, around of the x-axis. Of course, you can around the. I will speak on it, and also you will have in the test 3 again, if it will be the case. Then you will have also the example for that. And also, please, I would like to remind you again and again that if I am giving some example on the blackboard, so the similar, because this I am as you see, sometimes I am giving example which is not in the in your textbook as in the text in this section. So this is some kind of the modification, and then I am thinking that I am giving the in one hand this is contains some creative element. On the other hand, this is really, if you understood the lecture, then you will easily deal with the with your test. I am happy to say that I really very satisfied with your result on test 2. The test 2 is a really great step to forward in the with respect to test 1, and so at least I guess around the 15 people received the 20 points or similar. I don't remember exactly, but it's at least 2 or 3 times more as it was before. Okay, again, and now, so if we are trying to understand what's going on, so then in the case of volume of revolution, we are taking, we are considering like these, and together with all, together with this curve coming here. And then we are considering what is the inside. So then, and this is the volume of revolution. But when we are speaking of the surface, we are only considering what is happened when we are only making reflection of this curve. Not, we are excluding. And then, for example, it's really, now I will, last time I didn't give example. I gave the example for for the cylinder. Now let me just give the one exercises, and I will show you. It will be easy to compute. And the last time I gave you the formula, the formula S. If you have the given curve y is equal f of x, where f of x defined in say this segment between A and B, and then surface of revolution of this curve with respect to x-axis. I'm speaking with respect. Of course, you can look also the y-axis, but I prefer this because I will give also the a similar setting in exercises. This is a tendency. So then I told you, and then there is the formula. The surface of revolution is equal to pi f of x time the same things then derivative of this function. I already have it with you the consensus that sometimes derivative I will write f prime this square x. So then, do you see this part Blackboard good? Yeah, very good. So then, this is the formula. And then if you have in exercises, if you have some function f of x, then you have to giving this formula as it was in the test too. If you many of yours did quite well, then if you know the formula of shell methods for the formula cylindrical shell methods, if you do the formula, you have to just put and integrate. So the main things that you have to remember the formula, and then many of yours did this very good way. Here you will receive the function for which all this aggregate, so all this term can be easily computed. Of course, when we have the square root of some function, this is we know that in some cases what kind of what we have to do if we have the square root like this, and if the integral contain these, or now the x squared minus x squared. So that's my book. Part of the Blackboard good. Yeah, okay, very good. So I will write anyway here. And now this is the exercise. Let's consider now. Let us try to compute. So this will be similar if you have to compute the surface area. Compute surface area of sphere. With the radius r. So this is the exercise. And compute the sphere. We know that the volume of the sphere with the radius r is PR cube. All right. And now we are interested not what is the globe contain inside, what the globe contain inside, only its surface. So we are interested only its surface, and this surface can be is obtained from the following curve. Now let's consider the curve. Which in this form. Let's consider the curve. So what is so this is xy. This is xy. And how we can write the circle? First of all, let's consider this semicircle. Let's consider this semicircle with the center 0 and with the radius r. This is this curve can be written as you know x squared plus y squared is equal r squared. So this is and then if you would like to consider only semicircle, that means I will consider y more than that means we are considering only this which we have in the upper plane. Yeah? So this curve can be written as this. And now then you can easily see that this sphere can be obtained. This sphere can be obtained by reflection of the this semicircle with respect to x-axis. So then, if you have like this, then you will have this sphere, and again, then just sphere is obtained. Sphere means in three dimension. You have here hidden directions there. Huh? So I have here the hidden directions there. So the sphere with radius r, that means x squared plus, for example, y squared plus z squared is equal r squared. So this is in three dimension can be obtained by reflection of this curve with respect to the x-axis. And now I would like to compute surface area. And now, in order to compute surface area, I have to apply this formula. And in order to apply this formula, I have to write this equation as in the form y is equal f of x. So because if I have the given curve in the form y is equal f of x, then I will put this formula. I will take f of x and compute this guy, multiply 2 pi, then it's done. Now let's just deal with our curve. So that this is our curve, and from this equation it's followed. Y squared is equal r squared minus x squared, right? I can just put x squared to the, and then from here, since I am considering y is more than 0, then one can obtain y is equal r squared minus x squared. So this is my f of x. Y is equal to f of x. And now let's just compute this guy. So the S. Do you see this part good? Very good. So then S, now it will be where x is running. X running between minus r to r, right? This was the upper curve. That means from minus 2 pi, we have a 2 pi, and minus r to r. Just write it in this form, minus r to r. Now, f of x, so square root r squared minus x squared time. Now, if you take a derivative of this function, take a square and adding 1. So if you now compute this guy, we did last time this, when we try to find the length of the sphere, then you will obtain that r. It's easy to take a derivative of this function. if you take the derivative of this function, this is derivative of this function. This is your fx derivative, and then take after derivative square and add +1, then you will obtain the derivative. This guy, for this given function, 1 plus f prime x square, one can easily see that it will be r square minus x square. So for Kobe, you can compute it quickly and then see am I right or not. And then if I'll multiply this guy by r1 over r square minus x square, the x, they will cancel each other, and then I will obtain 2 pi r. So this is equal to 2 pi r time. So because I am taking this r outside of the integral, r is a constant, and integral minus r dx. So we know that this guy will equal 2r, and we obtain the finally 4 pi r square. So this is the surface area. Also, this is show that this is also a very good indicator for those who will in future deal with mathematics. If you are dealing surface, if you have some tank inside of the water, so then all this tank, this is already volume. Volume usually have the scale. If you have some side r, they has a scale r cube. If you are just looking the only not inside, just only lateral surface, then usually this is one-dimensional less. So you are not considering what is the inside total volume, just surface, and the 2-dimension means that the main parameter could have r squared. So that this what is very important for you, and then please what is very important for you, then you have to know that if you will obtain some similar exercises to compute a sphere with radius 1/2 or something like that, then you have to know that in the exercises will explicitly indicate, please compute surface area then via a reflection, or compute surface area. If you have the surface area, if you have the function, then maybe I will not give the function. So if I'm saying semicircle, that means that this semicircle, right? So then, even if in the exercises we will not given the function, so then if you have the compute surface area of sphere radius 1/2 or something like this, then you have to know that this function could not be given. It could be the case, and then that means that you know that the sphere can be obtained by the reflection of the semicircle. The semicircle has this formula. Now this gives you already immediately information that you are dealing with this curve, and then afterward it's really very easy to compute. And now after having this, which we learned last time, today I just give you the examples which will be very important for you. Now we are switching the very important object, which is called differential equations. So then this is the very important object when you are dealing with evolution, disease propagation, or when you are saying the mathematical modeling. when you are speaking on the mathematical modeling, that means that you are trying to describe the physical, biological, or mechanical processes via some differential equations. Now, what is differential equation? In mathematics, sometimes definition play much more important role than I would say than the others. Then now you have to understand what is the differential equation, and the simplest form of this differential equation you already learned. You remember that's antiderivative, right? So what is the antiderivative? Antiderivative means that the some function f of x is given. Some function f of x is given. And then now you have to find the sum of the function. We are saying the capital F. Then its derivative is equal f of x. That means that this is a very simple form of differential equation. So differential equation means that you are looking for some function is given, say the right hand side. Usually you can write the function is given, and now you are looking for the other function whose derivative, for example, in very simplest case, is equal f of x. We know that if you have f of x is say the cosine of x, so then we have to solve the f of the x. We have to find the function f whose derivative is cosine x. Of course, we know that this is f of x. In order to find the solution of this equation, because this is our goal, we have to just integrate right-hand side. Cosine x dx, right? Integral. So this, this is given, this function is given. Now we are looking for the f of x. Then we have like in this form, and we know that this is equal sine of x plus c. That means this equation has a solution in this form. This is the very simplest form because right hand side depends only in this form f of x, right? And now let's just give the general definition. So then you learn this is the from your the antiderivative. Again, that means the differential equation. It means that something is given, and you are looking for the function whose derivatives or the sum combination of its derivatives is equal to given function. And they are in more general setting. The differential equation could have in this form. So they just say p of x. Then allow me to write in this form. So we are looking for y is equal y of x. So we are looking the y of x, where this p of x is given, plus q of x, for example, y of x power n. So it could be anything, could be 1. Now you will see equation is equal the other function n. This is a general form. So then if it will be here third derivative, then you will call this the differential equation order 3. If it will be the highest order of derivative, highest order of derivative is called the order of differential equation. And then if it will be a third order, then we will say that so the order doesn't include in which power the unknown function is. If it will be here 5, 7, or 100, it doesn't mean doesn't have the influence of the order. Order of differential equation related the highest order of the derivative. And now, if I am saying the first order differential equations, that means I have the derivative only one derivative. And if here n is equal 1, so it could be n is equal 1, then you see that this will be first order of equation, because you can, I will come to later, you can divide to p of x, thinking that p of x is not equal 0. Then you see that here, when n is equal 1, so this is called the linear equation, because first order, first means the derivative is has the maximum derivative is 1, and also the expression of y of x is also has 1. And for example, if you have equation y of prime of x plus y squared is equal 1, so you are looking for solution. You are looking for y is equal y of x. You are looking for y of x, whose first derivative plus y squared of x is equal 1. And then this is the equation is first order, because the derivative appears in first order. But this is the nonlinear, because here the order the power of the unknown function is strictly more than 1. So this equation is called nonlinear. Nonlinear first order. If it will be a cube, again, so the n, when n is the strictly more than 1, and n strictly more than 1, this is called the nonlinear first order, because the derivative is the first order equation. And of course, if you are interested in the disease propagation and how the coronavirus propagate, then you have to this unknown variable. So you have to find an equation which is depend on time. Now, in this case, x, you can replace x as a t. T is indicate time. Now you are interested that in the beginning you have some infected population, and now you are interested that how propagate in 2 weeks when t is a time, and how it will propagate, and so derivative. So the derivative is equal some the function. Let me just write f which will depend on y of t, like, for example, like this, and then you know that what was in the beginning, how many infected. So this is in the beginning, at the point t0, that means initially we had infected 20 people, and now we are interested what will be evolution of disease when t will be after 20 days, or what we will expect in May, so in 1 month or in 2 months, so the 60 days. And now, in order to solve this, the disease propagation, you have to know the form of this given function. So now the lack of the data, the most from China, a lack of the data. If we know the function f, I will show you how in some cases how can solve this equation explicitly. Then we can, of course, we can obtain the solution, and we can say how the disease propagate. In other words, so then this disease propagation, because this is actual, the kind of situation. In order to find how the disease propagate, you have to know the right-hand side. The right-hand side must be given in order to solve the differential equation. But this function, mostly from one or other reason, is not explicitly given. And therefore, based on some data or reported data or unreported data, you are trying to construct this function. I did in my, I had a very big project, a very, very big project in the European Union, concerning for the completely other purposes, which we had, how the chemical, very important product, bring from the laboratory to the industry. And then it was some very important chemical product. And this function to construct this function, it was not easy because the industry do not provide us. And therefore, we have to make some phenomenological or some from many different sources to construct or to have some information on this function. The situation now with the coronavirus is the similar. So we have, instead of one equation, of course, 4 or 5. This is a system we have suspected, infected, recovered. And so instead of one, we will have this several equations. And then and how they are interact to each other. Then we have to have a lot of information. We have to test it, report it, unreport. And now, in order to deal with, I am speaking for your futures, and then if you will deal with the mathematical modeling, and everything, all of this process is described by a differential equation. It will be ordinary. Ordinary means that you have your function depends only one variable. Unknown function. It could be partial differential equation. You should forget about it because this is maybe you will learn in 2 or 3 years. Anyway, so this is a differential equation, which means that, and then this differential equation is not always this differential equation is solvable. Not always you can find this equation. So I will write in general form. Not always you can find even a solution of first order, because the derivative appears only the first derivative to solve this equation. However, in some cases, which is also not bad and also appears in reality, one can solve the differential equation explicitly. Explicitly means that you can find the way how to compute. One of these kind of the class of this differential equation, which is called separable differential equation. Now we are coming to the object which is called separable. Now you will see what does it mean. Separable differential. I will write like this equations. So separable differential equations has the following form. We are looking for y is equal y of x. We are looking for y is equal y of x, and whose derivative I will write again. I know that you like this form, the derivative, but sometimes if you don't mind, I will write y prime of x. So this is the same. So then we are looking for y is equal y of x. So we are looking for the function. So then sometimes they are writing this, but they're thinking that y depends on x, which is equal, say, h of x times j of y. That means that, so you are looking for the function, right-hand side, you remember in the case of antiderivative, we didn't have this term. You are looking at the sum function is given, you are looking for solution which has dy of the x is equal to h of x. That means you have to just take the integral of h of x, it will be your solution. Now, you have on the right-hand side the function which is a product which is a product of this function. The one depend on x, and other depend on y. So, and then one of the nice example of this, the y of x, the x, for example, is equal x times y of x, right? So the h of x in this case, for this equation, h of x is equal x, j of y is equal y. Or you will, if you can write, this is y. You can write, if you will write here x squared, for example, x squared, y cubed, then in this case, h of x will be x squared. Y cube of x, then jy, it will be y cubed. So you see that the right-hand side is separated. The variable of x, in other words, the right-hand side is a product of two functions, which is one depends on the variable x, and other depend on the unknown function variable of y. If you have this, then one can easily solve this equation. And then I will show you how it works in a general form. And then let's just start with this simple example. So let's just compute the y of the x. We are looking for the function y of x. Sometimes they are not writing like this. They are writing like dy of x, thinking that the function y depend on x. And then let's just solve this equation. X times y. Huh? So this is a separable equation, a separable differential equation, because the right-hand side has a product x and y. And then what we have to do, how to handle with this kind of equation. This is since this is separated, I can write this equation that dy of the x, so then the formula I can write, I can multiply both sides to d of x. Now I'm just speaking and for you how it must be done. You are multiplying both sides dx. And multiply. This is the formula. And then you'll multiply. Then you will cancel. Then you will obtain dy is equal x times y dx. If you multiply both sides by dx. And now multiply both sides 1 over y. So you will obtain dy over y is equal x times d of x, right? So then it will be 1 over a, and y and 1 over a will be cancelled. And then we will obtain dy of y is equal x times, so this x times the x. Now let's just integrate. If we will integrate, then we will have dy of y integral x times the x, right? So I'm taking from both sides. We know that dy over y, the integral of this guy is ln y. And put here even like this in order to be more realistic.
You like it.
Last time I could be Jordan.
Yeah.
Integral x dx.
It's the first. You can leave all the.
Integral. Now this is and then from here we can take both sides. If we will take e power from both sides, then we will obtain e power. If we will take e power from e power of this guy and e power of this guy, we will obtain the absolute value y of x is equal e power x squared over 2 plus c. And now for you it's very important that this is equal e power x squared over 2 times e power c. And this is we know that the rule of the power function a power x plus y is equal a power x times a power. Now the c was arbitrary constant, and e power c will be also arbitrary constant. Therefore, sometimes you can just replace d by other arbitrary constant, c tilde. So then, if you have this absolute value of this, then your solution y of x is equal plus minus, because if absolute value is equal something, then the what is stayed inside is equal plus minus c tilde is arbitrary constant time e power x squared over 2. You see, as soon as they are separated, as was in our case here, Kobe, is it clear? It's clear. Very good. So then we settle this. And this is a general procedure if right-hand side has this form. It could be, of course, the y of the x. It could be not as the y is linear. It could be the same x squared times y cubed, or dy of the x. For example, it could be e power x times y squared. So that then the strategy is the same. You have to bring the multiply the x and and after that multiply 1 over y squared and bring the form. In one hand, you have the expression on y. On the other hand, you are expression of x. It could be different depending on equation. And then integrate, and you know how to integrate. And in the test, you will have the functions, those integral, you know much more. But again and again, this scheme, its work, this scheme, that I would like to especially to emphasize, this scheme works if and only if your right-hand side is a product of the x, some function of x, like here the function x squared, and then the other function a cubed. And this scheme doesn't work, this scheme. So this is called the separable differential equation, and this scheme doesn't work in the case when we have the non-separable equations. For example, what is the non-separable? Just even the very simple equation, dy of the x, very simple, right, is equal x plus y, or dy of the x is equal x squared plus y squared, or y cubed, any kind. If not product, just sum. And the technique which I did before, it will not work. So this is the please, but nobody is perfect, and this the non-separable also non-perfect. We in some cases we can handle even more explicitly with the non-separable equations, and we can find the explicit solution. Explicit means that we can integrate. We can integrate the equation and in this form. Now, so this can be done. You remember this equation, which I am saying, this equation is non-linear. This is first order because we have the only derivative in the first derivative, but this is the non-linear because the unknown function on the right-hand side has the power is strictly more than one. And here, what we have to deal with, so that if you have this equation, the differential equation in non-separable form, So this is non-separable. The order of this is order is 1, but the non-linear, then it's very difficult to find a solution for non-separable equation. But as soon as you have equation, the first order and the linear, so this equation is linear. This equation is first order, and linear. First order because the derivative appears only the first derivative, linear because the function, unknown function coming in is the first power. So that this is y power 1 is y. So that therefore we are not writing. So then the general form of first order linear equation, first order linear equation is written in this form, first order. Now the first order linear differential equations is written dy of dx and plus, this is a general form, p of x. This could be any polynomial if you want. So this is given. Time y of x is equal q of x. So this is a general form of the first order of equation. First order of differential equation. And p of x, q of x, and q of x are given continuous functions. So they are given. And now we are looking for the y is equal to y of x, the solution of this equation. And we are looking for. But again, this is in general non-separable. So this equation, this differential equation, first order, is non-separable because in particular case, so this equation has this form. So this equation has this form, right? And then if you can just write this equation in this form, so this equation can be written dy of d of x. Now, p of x times y of x. If you will put this to the other side, it will be minus y of x is equal x. Now, for this equation, so this equation is non-separable because on the right-hand side appears the sum, not the product. For this equation, we have the p of x is equal identical minus 1. So because minus 1 to y of x, it will be minus y of x. And q of x is equal x. So then so the non-separable equation in general, you cannot find the solution in the explicit, or you cannot integrate in general. But as soon as you restrict yourself to the first order differential equations, this is a linear, and this also has the meaning because we are everything in mathematics in real life. We are starting as say the Einstein. Everything must be made as simple as possible, but not simpler. We are starting with a simple case, and then the later step by step we are trying to solve. For separable equation, we don't care at all. So this is the non-linear or linear. As soon as the separable, then we can do the technique which was before. And but as soon as you have the non-separable, which is in particular the first order linear equation, or this as a particular case of this equation, then you can solve. So the advantages of the linear equation, the linear differential equation, is that it doesn't depend. It's separable or unseparable. We can always solve this equation. Then in next lectures, so I have a time. In next lectures, I will show how it can be solved in general form. But today I would like to just to show you how that one easy way to show the patterns of how we can do it, and then this technique will be in general the same. Now let's just consider the following equation. Now we are dealing with a non-separable equation first order and with simple example. So what you prefer? When I am writing with red or when I am writing with blue, which is better to see? Red. Okay. So fantastic. So let's just consider the equation of this form: dy d of x plus the 1 over x y is equal to, as is this is the equation which you can find in your textbook. So let's consider this is the first order. This is first order of differential equation and linear, because this is first order due to this term. Linear because we have the unknown functions appear the y. And so in order to solve the first order of differential equation, you have to multiply. So that the main idea is that you have to multiply this equation to the something which we later I will show you that it can be computed explicitly. Then bring this equation to the other simple form, for which you can integrate. For example, so this will be general too, but I would like to show you in this example how the general strategy will work. Yes, now they multiply this equation both sides by x. Then on the left-hand side, we will have x times dy of the x plus y is equal to x, right? So if I multiply both of sides to x, it will be to x, it will be x times dy of the x, and then x and x cancel, then you obtain that. Now the left-hand side, I can write, so this is it, the main idea. I can write left-hand side x times y. So if you take a derivative of the product x, it will be y of x plus x times this. So left-hand side is equal to that. And the right-hand side is the 2x. So that means we have to, we know that if the derivative of this equal to some function, then what is the inside of derivative is the integral for that. From here, it follows x times y of x is equal integral of the right-hand side, 2 of x, which is 2x dx, which is this guy is equal 2 times x squared over 2 plus constant, right? Because 2 you can put that, 2 and 2 they cancel, and then right-hand side will be x squared plus c. Now my goal is to find y of x. Now I will divide both sides to x. Then from here it follows y of x. So I'm dividing both sides to x, and y of x is equal x plus c over x, where c is arbitrary constant. Then I solve this equation, even if this is non-separable, because if you put this as the left-hand side, then you will see the difference of this. This is non-separable, and then if you multiply this to x in this particular case, then you can solve this explicitly. And now the idea, the main idea is if you have not in this special form, if you have like in general form, you have the general form where P and Q an arbitrary function. Note this is here 1 over x and 2 arbitrary. What is the rule? The rule is the similar. To find something, when you will multiply these both sides, to find such which is called the integrating factor. You have to find some function, given function. When you multiply both sides to this function, then the left-hand side will be derivative of something to equal the given function. And then if derivative is equal to something, then the function under the derivative is an integral of the right-hand side. And then we can solve the equation of the first order of a linear equation, and then you will see that this is the in the case of the linear, you can solve this equation explicitly without this is separable or non-separable. But this is work again and again only for the linear equation. For the nonlinear equation, this method doesn't work, and then the only hope that what you can do, that your equation will be separable. For a separable equation is good for nonlinear, both for nonlinear and the linear separable equation. But for non-separable, if you have nonlinear, this technique doesn't work. But if the non-separable equation is a linear equation, which has in this form, then I will show you the explicit formula how it looks like the solution. And in particular case, when we will take P of x and Q of x like here, then we will obtain that we have to multiply to that. Thank you very much for your listening, and then see you on Friday. Bye-bye.